This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today my guest is Dr. Keith Leatham, who's an associate professor in the Department of Mathematics Education at Brigham Young University. Keith, thanks so much for being here.
I'm happy to be here, Sam.
We're going to be talking about Keith's article in the Journal of Mathematical Behavior entitled The Case of Benny, Elucidating the Influence of a Landmark Study in Mathematics Education. So a lot of you might be familiar with the case of Benny. We're going to get to dig into that quite a bit. But Keith, before we get to Benny, let's just back up here to the case of Keith Leatham. So where was it that you did your graduate studies, and what did you focus on for your dissertation?
Great. So after I did a master's degree in mathematics at Utah State University, I went to the University of Georgia. That's where I did my PhD. My advisor was Tom Cooney. In part, building off of the work that he'd done on beliefs, I also studied beliefs. My dissertation study was on pre-service teachers' beliefs about technology in teaching and learning mathematics.
Mm-hmm. So Benny is a little bit different than that, although I'm sure related in a lot of ways, especially with beliefs and things like that.
Right.
So here, in this article, you really dig deeply into the case of Benny. And Benny is something that a lot of people in math education are probably familiar with, but maybe not everybody. So first of all, we'll back up and we'll just talk about Benny a little bit. For me, I was introduced to Benny in my very first graduate level doctoral class in mathematics education. And a lot of people might know Benny from the Classics in Math Education volume that was published by NCTM.
Yep.
But could you help us out just with a quick nutshell of Benny for people who maybe haven't read it or aren't familiar with who Benny is?
You bet. So first of all, I would say, if you're listening to this podcast and you haven't read The Case of Benny, you pause and go read it. And then continue on. I mean, you really ought to read that case. It's fascinating, and I think it's foundational for anybody who's engaging in mathematics teaching and learning, and also in doing research in mathematics. Mm-hmm. Mathematics teaching and learning, that is. So basically, The Case of Benny is a case study of a 6th grade student. Stanley Erlanger went into Benny's classroom, and Benny's a pseudonym for the student, and went into his classroom and observed how he was engaging in his mathematics studies in that classroom. And then Erlanger did interviews with Benny to try to understand what was going on. The reason that he chose to do interviews with Benny is because he, in his observations, realized that there were two kind of interesting things going on with Benny. Benny was doing pretty well. The curriculum that he was using was one where you worked individually through workbooks, and then as soon as you'd worked through the materials, you went up and took a quiz to see if you'd mastered the material.
Mm-hmm. It's kind of like the 1970s equivalent of like online-based individual sort of learning modules, I would say.
Yes, definitely.
And now we've moved them online where a student sits at a computer, they go through these modules, they take a test. If they pass, then they move on to the next module, that kind of thing.
That's exactly right. It was meant to be individualized, to be very prescribed according to specific learning objectives, and broken down very, very procedurally into each of the individual components one might need to understand in order to carry out a particular procedure. Mm-hmm. So Benny was making pretty good progress. He might not pass the quizzes on the first time, but he would quickly get through the material and pass the quizzes and move on. And so he was doing quite well in the class. But as Erlanger observed him, he realized that he was doing some really kind of unexpected things with the mathematics, things that were incorrect in terms of the way he was carrying out the mathematics. And so he was fascinated by this situation and wanted to understand more about Benny's particular situation. Going into this study, all along it was Erlanger's intention to look at the mathematical behavior of students, to get inside their heads and figure out how they're making sense of mathematics and how they're viewing mathematics and what it means to do mathematics. So his intention was to look at what he termed students' mathematical conception, which is like what I just said, basically the ways they see mathematics, the nature of mathematics, and what it is for them.
Yeah.
And so the case of Benny basically describes Benny's situation, and in a nutshell, there's much more detail both in the published article that focuses on Benny, as well as the other kind of incarnations of the case of Benny that exist in Erwinger's dissertation. The case of Benny is just one of 6 cases in his dissertation.
Okay.
But basically what we find out is that Benny was very much trying to please the teacher and the teaching materials by getting the correct answers, and he developed his own kind of methods and ways of reconciling the fact that sometimes when he worked a problem, he would get a different answer than what the answer key had. And his way of reconciling that was to overgeneralize the idea that we have multiple representations for numbers. So, I mean, he would use examples like, well, 2/4 is equal to 1/2, and even though they don't look the same, they're really the same. And so he used that in order to justify when he got an answer that wasn't actually equivalent to the answer key. He would say, oh, well, they're just looking for it in a different form. So he believed that he was still right. And so he could reconcile these contradictions in a way that wasn't mathematically correct, but that you can see was kind of connected to a mathematical idea of equivalence.
Yeah.
And so he would revise what he was doing slightly in order to get that particular type of problem correct in the way that the answer key wanted the answer.
Right.
So that's really the underlying story of Benny, is how he managed to create this mathematical world that didn't match up with the mathematics really that was intended by the curriculum or by his teacher.
Yeah, and he also could progress through to the next module and continue on where he's looking from the surface like, oh, he's being successful, he's moving through these things. But because he's holding these contradictions in his whole image of what's going on, he actually doesn't, just to put it bluntly, he doesn't understand very much mathematics correctly or completely, but he is progressing through successfully. That's because right. He's willing to just have it, oh, here's how I did it. It's different in the answer key, but they're both right. I'm just going to keep going. So he's kind of progressing through with misconceptions and errors and things, and not really full conceptual understandings.
Yeah. So in many ways, he viewed his experience with the curriculum as a particular kind of game, and he was winning the game. It just wasn't the game that was intended. Right.
So in this article, you take the case of Benny, and it's had a lot of influence in the field of mathematics education, and you analyze how it has showed up in the field of education. Before we get there, I'm curious how the case of Benny first showed up for you. Where were you first exposed to it?
Yeah, so I think my experience was similar to yours. One of my first graduate courses in math education at the University of Georgia, we read the case of Benny in that class. And it was a class where we were being introduced to literature in mathematics education. And I still remember, first of all, reading the article and thinking, wow, this is exactly the kind of thing that research in math ed should do. Like, I remember thinking, that's the kind of stuff that I want to do. I want to better understand the way the students think about mathematics. And there were also lots of implications for teaching, and so the combination in the paper of looking both at student learning and at teaching was really fascinating to me. So the second thing that I noticed when I was reading through that case of Benny is Erwinger managed to pull enough information from Benny in order to kind of figure out the rules that he'd come up with to try to get his answers. So I mentioned that he had some ways of getting answers that just didn't jive with what was intended, that weren't really correct mathematically. But he managed to figure out what he would do, so he would know how Benny would perform on a given problem. He knew the kind of error he would make. And I was also fascinated by that because you could go through and see particular subsets of problems, for example, where Benny's strategy would work. And then, of course, a majority of situations where it wouldn't. And so there was something inherently mathematical about the analysis that I also found really compelling.
In the Journal of Math Behavior article, you have the case of Benny, and here what you actually do is you take this landmark study from the 70s, and now you're going to trace how it's been cited, how it's been used, what its influence has been in the mathematics education literature. So this is a different kind of article than we're used to seeing, but a really interesting, fascinating one. I was wondering if you could just let us in on how did you go through that process? What was your method for this kind of study where you're studying the influence of another study?
And in part you might be wondering, why would you even think to do such a thing?
Because it's interesting and fascinating, that's why.
That's right, because we can, right? So one of the great things about this job is we get paid to be creative and just explore and learn. So it's a wonderful thing. So over the years, I've always been fascinated by the way that we cite the work of others. I think it's such an interesting aspect of academia and the kind of the genre of writing. And when Google Scholar came along and search engines began to allow us to basically to search backwards, right? To be able to look at where things are being cited.
Mm-hmm.
It started to open up these new possibilities, and I in a graduate seminar that I teach, I would often have students use that search engine in order to find a couple of places where somebody had cited the article that we were reading, and then look to see how they were citing it. And in doing so, gave us some things to talk about, some starting points for discussing the article, and also is a chance to learn a little bit about the writing genre. So there's kind of a natural extension from there as I started thinking, this resource, being able to search backwards for a particular article would give us the ability to actually track how people are using the article. And then, so I got this idea of maybe I should do that for some article, and a natural one to do it for it seemed to be the case of Benny, because I saw it as so kind of fundamental. And when I went into Google Scholar and I looked at a number of different articles, the case of Benny actually isn't anywhere near the most cited in the math ed literature.
Mm-hmm.
So I thought that was kind of interesting, that it isn't by any stretch the most cited, and yet many people talk about it as being so influential. At least that had been my experience.
Mm-hmm.
That I thought, oh, maybe this is a perfect one to choose for that very reason. And also, it would be manageable. The number of sources, right, would be such that it might be reasonable to actually try to track them all down.
Mm-hmm. Yeah, so then how did you find the articles that you were going to look at? And then when you had an article, what did you actually code for, or how did you then make sense of what was in those articles?
Yeah, so we used Google Scholar as the primary source, and basically, search for the case of Benny in Google Scholar. It brings up the case of Benny, and it shows cited in, and you can click on that, and it gives you a huge list of articles that have cited Benny. Mm-hmm. And so we used that as the basis. We located each one of those articles, verified that they didn't indeed cite the case of Benny. So, for example, sometimes Erlwanger's Erlwanger 1973 ended up in the references but wasn't actually cited in there.
Oh, yeah. Right.
But made sure that it actually was one and got a copy of it. Then there were a few other things that we did to try to see how good Google Scholar was at its job. It turns out it's really good. But we looked through some journal websites. Like, we went to the Journal of Mathematical Behavior's website and searched for the case of Benny there to see if there were any articles in that journal itself that maybe we were missing, and went to ERIC database and some other places just to see. And we found a few here and there, but not very many more. Google Scholar really did a great job of capturing it. So then once we had an article where they'd cited Benny, then we looked through the article to find any place where they cited Erlwanger. And then we treated that location as a citation instance. And then we read over what they'd said, and we asked ourselves a couple of questions. First of all, we asked, what's the point that they seem to be making? And sometimes we would word that as, what's the claim that they're making? And then we would ask, okay, so how are they using Benny to support the claim that they're making?
Okay.
Or another way of putting it, we would say, so they're appealing to Benny for some reason. What seems to be the reason? How is Benny supporting whatever it is that they're saying? Okay. And at that stage, it wasn't an analysis of whether Benny actually did support what they were saying.
Right.
It's really just a question of how they were using it.
Yeah, I think that makes sense. It's like, how has this been picked up and used in the field? It's not really a judgment of whether that's a correct use of Benny or the most valid use of Benny. It's just, how is it being used?
That's right. Then, because we started to notice a lot of times the use seemed a little bit off, we also started to make note of places where it seemed like they were using Benny, but maybe not quite as they should. So we also took note of that, and that's not reported in this paper, but we also were analyzing that.
My guest is Keith Leatham from Brigham Young University. We're talking about his study, The Case of Benny from JMB. So now, then, the next natural question is, what were the different ways that you saw Benny being cited or being used in the field of mathematics education?
Yeah, so far and away the most common reason for citing the case of Benny is wanting to make a point about students' conceptions of mathematics. And what's interesting is that Erlanger defined conception as both their knowledge and beliefs about mathematics, and so people can use the case of Benny to support kind of the importance of understanding that whole collection of things. So you have people citing Benny to support statements about knowing how students think about mathematics and knowing their understandings, their particular ways of doing it. Doing mathematics, and then you also have people citing Benny in order to support their work in looking at students' beliefs about mathematics, what it means to learn mathematics, the nature of mathematics, things like that.
Mm-hmm.
So that's by far the biggest collection of reasons is related to that. And when I say that their purpose is related, there are lots of different ways, of course, so that you could cite Benny to support you when you're studying student conceptions. So you might cite Benny as an example of people who have found insights into students' understanding, and then because you want to say, look, I'm not the first person who's done this. I'm doing something that's in a similar vein to other work. So that would be one example. Or they would appeal to particular conceptions that Erlanger uncovered for Benny, and they would want to be making connections between the conceptions that they maybe have uncovered in the students that they're studying.
Right.
So
yeah, make a little link there. Yeah. Other ways it was used.
So the second most common reason that people cited the case of Benny was related to this phenomenon that Benny was making progress despite not understanding the mathematics the way the curriculum wanted him to. And so I captured that idea by saying people are basically making the claim and citing Benny to support it that correct answers don't necessarily imply understanding.
Mm-hmm. Yeah, that was kind of how I cited it at the beginning here when I added in my little thought. I was kind of almost in that category.
Yeah, and so that's a very common reason to cite the case of Benny, that phenomenon. And it's actually related to the third most common reason, which was really that people cite Benny in order to point out or to support claims about the limitations of behavior style curricula. These curricula that try to break down student understanding into just observing behavior and seeing whether they're able to carry out those behaviors are really missing a lot of the underlying understanding that needs to be evaluated in order to get students where we want them to be.
Mm-hmm.
So those are pretty common purposes. Now, one thing that I found quite interesting is that another common purpose for citing the case of Benny was actually to cite it as an example of qualitative research. So a lot of times people weren't citing the case of Benny because of his findings, but we're citing the case of Benny because it was viewed as exemplary in terms of the type of research.
Yeah, like a case that's very compelling and that makes a difference. It's a case that responds to important issues in the field.
Yes, exactly. So it's this example of why case study methodology might be useful and valuable and legitimate, because it illustrates in so many ways the qualities that we expect in that kind of research.
Mm-hmm.
The fifth one that we identified that was kind of big enough to be of note was this idea that students in a classroom are always making sense of their environment. That's just a natural aspect of learning, and that we need to treat them as sense makers. So when we see, this idea would be that when we see students doing particular things, it's not like we just need to target their behavior and get them to stop doing one thing and start doing another, but we need to really understand why they're doing the thing they're doing. So, Erlanger's point was that this wasn't, in a sense, it wasn't Benny's fault that Benny was thinking this way. He was simply taking his experiences and making sense of them.
Mm-hmm.
So the environment that he was in many ways contributed to to where he found himself in terms of his mathematical understanding. And so the argument would be that we might want to attend to the environment to try to make, I guess one way of saying it is we want to make the experiences that our students have worth making sense of.
So I'm just curious on your thoughts as you've thought about Benny a lot and seen how people are using Benny. Have you been able to identify what it is about the case of Benny or about Earl Wanger's work that has led to it having this large impact and multifaceted impact over the decades?
Well, I have a couple of thoughts on that. One idea really comes from the introduction that Michael Shaughnessy puts in that classics book that you mentioned earlier, Benny's Classics in Research. And he points out that he was a graduate student at the time when this paper came out, and they were blown away by it. Like, at the time, there were some big issues at play, and in particular, there was this issue of behaviorist curricula. That was a big deal at the time, and people in max education had many doubts about it, and so this article just brought out this idea that, wow, look, here's something that will allow us to kind of articulate some of the concerns that we've had. And so it came out it was very timely in that sense. And
it kind of filled it's kind of like what a lot of people wanted, right? They probably wanted some evidence and this story to hold up to help voice their critiques.
That's right. There was a general sense that this was a kind of issue with this kind of curricula. And that's right, this provided some evidence to back up those claims. The other thing at the time was that this was a poignant example of qualitative research, and qualitative research was not that common yet. And so it was also, if you look at a lot of the research that's published around this same time, in the early 70s, so much of it is relying on quantifying situations, and it just, that methodology just didn't allow people to answer certain questions. And this methodology allowed Earl Wanger to answer questions that many people at the time were saying, yeah, we need to be asking these questions. And this is a methodology that will allow us to try to answer them. So I think that the methodology itself and showing how the quality of results that you can get with these kinds of qualitative methods was also really striking at the time. So it has to do with the timeliness, I think, of Benny. And that's one of the points that Shaughnessy makes in that preface, in that introduction. But the other thing I would point out is, I think the other reason is, as in this analysis, in revealing these primary reasons why people cite the case of Benny, I realized that when you look across all of these reasons, this really captures kind of the heart and soul of research in mathematics education. These are many of the big ideas. And so when you have many of the big ideas in mathematics education research being addressed in one particular article, I think that's another reason why it gained so much traction.
And putting all this time and energy into looking at the influence of Benny through the literature and through the decades, what would you say you feel is a new insight that you've come to because of the work that you've gone through, and then that you can kind of contribute to the rest of the field by putting this study out there?
So I think one contribution might be the methods that I used here in order to study the influence of this paper, because I think it would be fascinating to do other such studies in math education. This is a type of research that might be very interesting to the field, and in particular to us understanding how we're building on the work of others and the development of our field. So I think in that sense, it would be interesting to maybe see more of this kind of stuff.
Yeah.
With respect to Benny, I feel like, at least for me, now maybe other people have made these connections before, although I didn't really see it in the published literature. But for me, what was striking was the connection between the research methodology that Earl Wanger was using in order to carry out his study and the behaviorist curriculum that he was studying were in direct conflict. So I guess I saw this parallelism between Earl Wanger's basically saying quantitative positivistic research won't answer the kinds of questions we need to ask. We need a different kind of methodology. Qualitative research is something that would let us answer the kinds of questions we need to ask. And so he's putting out this new way of studying. And at the very same time, what he's studying is a situation where these same sorts of paradigms are dictating the curriculum that Benny's using. And that curriculum is not looking closely at the way Benny's thinking, but instead just looking at his behavior. And so there's this interesting parallelism that there's the same the solution for studying Benny is the same thing as the solution for Benny's own mathematical learning.
Mm-hmm. Yeah, it's kind of like he's pointing out, Benny is getting these answers and going through this behaviorist curriculum, but he's not really understanding the mathematics that are important to understand. And so it's kind of this, if you read between the lines, which I think is what you're kind of revealing with your study, reading between the lines, he's also saying to the field of mathematics education research, if you just do this, if you quantify everything, you get your answers, but you're not really understanding the important ideas that we need to be understanding, and maybe qualitative research can help to fill in those gaps.
Yes, yeah, exactly.
I think that's really interesting, and it's great to be revisiting Benny because he is just an interesting character. He's one of these characters that's just kind of, in our field, and it's good to revisit him, see how he's being used, so I really appreciate your work. I do, though, have a final question before I let you go. And this is the kind of fun question that's from my friend Aaron Brackenecki, but I've been stealing it from him and using it in all my podcasts. I'll basically ask you to imagine an alternate universe where you are not in mathematics education. What do you see yourself doing?
Well, two possibilities come to mind. In one of these universes, I definitely would see myself as a lawyer.
It seems like you're willing to sift through the past legal precedents.
That's right. So that aspect of lawyering, the research involved, and looking through the logical arguments to find particular ways of making your case, that seems really interesting to me. And then just the notion of getting paid to argue is really appealing to me.
Mm-hmm, sure.
But I do have a really difficult time envisioning myself in any universe not being involved in teaching. And so for me, the other way to ask that question is, if I wasn't teaching mathematics, what would I be teaching?
Mm-hmm.
And the only thing I can imagine that really, that I feel like I could teach with a similar kind of passion would actually be religion. That's just something that for me is a huge part of my life. And I could imagine getting as excited about, teaching religion classes as maybe I could mathematics. But that's about it. I can't really imagine another content area where I might be able to have the same kind of passion.
Right.
So I don't know I'm not really trying to make the claim that I view mathematics and religion as on par, but I do have passions for them, I guess, in some ways.
Right,
So,
yeah.
I guess that says more about my view of mathematics than anything.
I've been speaking with Keith Leatham from Brigham Young University. Keith, thanks so much for being here.
Hey, Sam, it was a real pleasure to talk about this stuff.
Thank you for listening to this episode of the MathEd Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.